All right. So guys, let me ask you, what is happening? What's the big thing happening next week?
Midterm.
Yeah. You remember exactly what day?
Thursday.
Yeah. So, and then what's happening the week after that?
Spring break.
There you go. All right. So you can kind of see Jeff's planning here. Midterm right before spring break, so that I then have actual time to grade the midterm. The midterm is going to be during class with your cameras on. So you must be in the class to take the test. Does that make sense? I've had people in the past not log in and take the test. No. Any questions about? I will have a practice midterm. I'm probably going to put it up. Well, we'll find out. We'll all find out together when that gets put up. And then I'll have like I'll probably make a solutions video for it. So there will be a practice midterm. Okay. Any questions? I think a few more people just came in. Any questions from the quiz or from homework?
I have a homework question.
Yeah.
For section 6.1, number 57. I'm just confused on what it's asking.
6.1. Here we go. 50. Oh, okay. This is such a cool. All right. Of course, I would love this problem. This is a funky ass problem, and I love it. It's a little difficult to understand what they want. So the annual percentage yield is the actual interest rate earned on a compounding account. Okay, so let's talk about this for a little bit. Let me see how lazy I can be. No, get off your ass. Okay. So formula for the amount made from a compounding account. So what does compounding mean again? Anybody remember what compounding means?
Put together interest.
Yeah, put together. I like it. So you add money and then you make more interest on top of that interest money that you added. So it just keeps compounding on itself, right? So that's where that word comes from.
Interest on the interest.
Say again?
Interest on your interest.
Interest on your interest, exactly. So it's money working for you, and it must be nice. So the formula is this in general, and we actually kind of developed where this came from. But let me run through a scenario real quick. Let's say I've got $5,000 and I put it into something that compounds monthly. This is roughly English. Into what are you gonna do, Jeff? 5% account. I like it. That compounds monthly for 3 years. Okay. Let's throw all this shit together. So I start with $5,000, right? So how much am I going to have at the end of 3 years? Well, let's see, 1 plus the rate is 5%, compounding monthly. So the N is 12 to the 12 times 3. Because if I'm doing it every month for 3 years, I'm doing it a total of 36 times. That's why this makes sense. I'm doing this 36 times. So somebody help me out. Oh, I left out a 0, didn't I? So what is that? My calculator is low on battery. Shit. Poor little dude. All right, who's got that? Anybody got that? Anybody?
It's like 6,351.2.
No.
Oh, I see.
It's
I
not
messed up
that
with the
far
decimal.
off, but it's a little bit off. Anybody?
Alright.
What's going on? Are you guys having trouble putting it in the calculator?
5,262.37.
Not quite. All right, let's see. I'm not sure what's happening. So let's do this. Oh. All right, so 5,000 times Noja 1 plus 0.05 divided by 12 to the 36. Is it because you're doing 3 times 12 instead of 36 and your calculator is doing 2 to the 3rd power and then multiplying by 12 because it knows order of operation? So you got to be careful. If you want to put 2 to the 3 times 12, you got to do it like this. But I don't think that's what happened. I'm not sure what happened.
That's what I noticed I did wrong.
Okay. Or you did 2 to the 12. Ah, you did 2 to the 12 times 3. That would make possibly some sense. Okay. Is that okay? 5807, 36. All right. So that would put 5807, 36. So how much interest did I actually make?
$107.
807.36. So what was my actual rate?
Actual rate for what?
The actual interest rate that I made. So like, let's see, how do I want to say this? Yeah. So the actual interest rate I made. So how much money did I make? I made $807.36 off of how much money? $5,000, right? So did I actually make 5% more? Did I make 5% of 5,000, or did I make 15% of 5? What was my actual overall rate that my money grew at? So it increased by $807.36. And where did it start? 5,000. So I would do 807.36 divided by 5,000. What is that? That's all you got to do. Right? It's just divide that. What's happening?
Like about 16%.
It sounds about right.
I got 16%.
Yeah, 16.15%. I like it. So you would think if I'm doing 3 years, 5%, it should be 15%. But of course, it's more than that because I'm adding money in the middle, right? Now, what the shit does this have to do with that problem? Well, what did we do? Didn't we figure out the amount? We figured out the amount. And then how do I figure out the, we do it like this. This is the amount in the account, right? How do I figure out how much interest? How did we get this number? What did we do? So first we got this number, which is this formula. How did we get how much interest we made? What did I do? Yeah.
Subtracted the original amount.
Subtracted the original amount. And then we divided by
Also the original amount.
original amount. What happens to all the P's?
Do they
Cancel.
cancel each other?
Okay, that's as much as I'm going to do. I basically did the problem for you, but yeah, that's it. It's kind of neat. It's like a little bit neat. But that's the idea of like, so guys, listen, if there was a 10% off sale and they go to the register and they take 10% off and they're like, oh, we'll take another 10% off because, I don't know, we feel like it. Is that 20% off?
No.
Of course not, because the second 10% is of a lower amount than the first 10% was. So that's what this is all about. I'm not going to get 15%. I'm going to get more than 15% because the intermediate percentages were of bigger amounts. So this whole problem is just, is there an expression for the actual growth rate of my money? Is there an expression for that? And that's what the problem is all about. All right, I missed some chats, but I don't know what they had to deal with. Okay. Number 2 on the quiz. Is that all right for that problem? Do you guys understand that I basically finished the problem for you? If you don't, then I'm sorry. So number 2 on the quiz. Let me see, what was that? Number 2. Here we go. Oh, so that was the, oh yeah, that was the slant asymptote one. Let's see. So I was talking about that earlier, but we can go over this again. Was there a specific question about number 2? Or just, were you not sure how to find the asymptote? Kurt? Was there a specific, not sure how to find it? Oh, can somebody tell me, how do you always find, in what situation do you need to be in to have a slant asymptote?
The degrees are the same.
No. That would be a constant division, so it would,
Top degrees higher.
top degree is higher. I like it. So that's the situation you have to be in. The top must be a higher degree than the bottom. And what do you do to find the slant asymptote?
Divide.
Divide, long divide. So I really want to be able to use certain terminology with you guys. It makes talking a lot easier. So when you divide a number, like if I divide 11 by 8, right? I get a whole number part and I get a fractional part, correct? Right, because 3 is the remainder. Okay, you're all like, of course, Jeff, good Lord. So when I divide polynomials, same thing happens. I get a whole part and then I get a remainder fractional part. Are you with me? The whole part will be the horizontal. Now listen. You guys have got to understand that, especially once you get into pre-calculus, if not intermediate algebra, you've got to start to realize there's computational mathematics, there's easy as shit mathematics, divide, multiply, bullshit, and then there's concepts behind what you're doing, right? So what's the concept behind horizontal asymptotes? I think I just said this a little while ago. What is it that gets us to horizontal asymptotes? Letting what happen?
The variable get huge.
Let the variable get huge, positive and negative, right? That's why it's related to end behavior, the things that happen at the ends. What can happen in the middle? All kinds of weird shit. Well, what must happen when x gets really, really big? It's got to follow this thing. So apparently I'm back to being lazy. Oh, if I wanted to know what the slant asymptote was, I think this is the one I did earlier. For this, does this have a slant asymptote? Yes. Degree is higher on the top. If I divide, I'm just going to do it real quick. If I let x get really, really freaking big, what happens to this piece?
It just about disappears.
It disappears. Goes to 0. So this is the slant asymptote. So when x is not really big, does my function have to be close to this? No. I really, and do you see the computational part? if X is really, really big, then this piece is much larger than this piece. So it's basically this. This is not really doing anything. So if X is 1,000, this will be 1,002 plus basically 1/1,000, right? 0.001. I mean, what the hell? That doesn't do shit to it, right? If I had $1,000 and you're like, here, let me donate a penny. You're like, oh, thanks, man. That's really, thanks so much. It really didn't change anything, right? Okay, maybe. Don't get me wrong. If you got a penny, it's all you got. You're going to donate. Go donate. Every little bit helps. But relative to what there already was, it really didn't change things much. All right. Is that better? So, I mean, the slant asymptote will be the whole part that's left because the fractional part goes to 0 when X gets really big. So what this means is, here, this is better than the parabola problem I gave you. This is easier to comprehend. Oh shit, I lost you guys. There you are. If I graph this in my calculator, so let's put this in here. What was it? X squared minus X, no, plus X minus 1 divided by X minus 1. And I also plot X plus 2. And look, I got nifty colors. Yeah, buddy. So if I graph these things, I'll see this. Now I got to zoom out a little bit. I don't know why I'm zoomed so weird. There we go. What's happening here? Why is it doing weird shit here? What part of the graph tells me there's going to be weird shit? Or what part of the function?
The dividend.
Yeah, there's going to be a vertical asymptote at 1. Do you see that?
Yeah.
Yeah, so that makes sense. So there's a vertical asymptote at 1. You can see that. But when X is close to 1, it's doing its own thing. But the bigger X gets, what is my outputs? What are the outputs doing? They have to get really close to X plus 2. So that is the slant asymptote. It's an asymptote because the function has to get close to it. And it's slant because it's freaking slanted. Right? Now, slant asymptotes don't have to be linear as we talked about in class, as you saw on the test, on the quiz. They can, of course, be parabolic. Or they could be anything, really. It just depends on how different the degrees are between the top and the bottom. Why was this linear? Because there's a power of 1 difference. That's why. Right? Okay. Okay. Is that better? Does that help? So the short answer is long divide the shit. And whatever the main thing is the answer. Yeah, now you just plug it in the calculator, just like I did. You just plug in the uglier functions. You got to make sure. Do you see what I had to do? The first thing I had to do? I think when I first opened this, because I was doing stuff with people earlier, I think my window was like this. How did I know that no, Jeff. Jeff, you can do it, buddy. There you go, my friend. So how do I know? Well, it's even worse. I don't know what it was. How do I know this is not showing me enough?
It's not showing. It's not showing the other parts of the graph, like the other quadrants.
True, but do I even see the blue line getting close to the red line at all? It sort of teases that it might if I look further back, but I don't see anything happening on this side. So that's why I'd have to zoom out to some degree. So you might have to zoom a little further out to make sure you see the function getting closer to your asymptote on both sides. So that was a mistake a few people made, was you just didn't zoom out far enough to see the whole thing. You can even use the zoom out function. Zoom out. Enter. It does exactly what it sounds like it's going to do.
All right. So is the blue line really close to the red line here?
Yeah.
Is it true? Is the blue line right here
No,
close-
over there, it's nowhere near it.
nowhere near it? Why does that not matter? Because X is only like 1 here. Who gives a shit? It only has to be close when X is big. Do you guys understand? So that's the idea of asymptotes. You don't have to be close to them until horizontal asymptotes until X gets really big. And the same thing with vertical asymptotes. I don't have to be close to vertical asymptotes until X gets close to the problem spot. So if X is not close to 1, I don't have to be close to the vertical asymptote here. But the minute I start getting closer to 1, now I've got to get closer to the asymptote. Okay, I'll stop. Is that okay, guys? Is that better? Or is that no good? Did I have it made it no better?
It helps.
A little. I don't have to. You don't have to lie. You can tell me. And I'm not saying you're lying. That's part of my job, is to figure out how to explain something a different way. Just a little. Okay, I thought you were saying just a lie. Okay, I think the parabolic, I don't blame you. I mean, the parabolic part makes it weirder, but it's the same idea. If you got a parabola as a asymptote, you got to get to the point where you see. So if I do this, if I make this a cube, let me see, which means I'm going to have to do this. Let me take this out of here. Now you could already, now this is a much simpler equation than I gave you. Can you already see the ends of it being parabolic? If I zoom out a little bit, now can you see it, the parabola part?
I don't think we can see what you're trying to show us.
Oh shit. All right, sorry, I forgot. I love you guys. Everybody except, I think it was Austin just told me. You're all like, it doesn't matter, I don't know. All right, can you guys see the parabolic nature of this function? So what I did was I changed the top to be a cube. So this is obviously not a parabolic function. This is a rational function. But when I divide it, the whole part is parabolic. So it wants to be a parabola. It wants to be a parabola. Poor little thing. But in the middle, it's going to do some weird shit. It's only when X gets really big that it's going to be parabolic. That's when it's going to lose, I know. That's when it's going to lose this piece. But when X is small, which one is bigger? When X is close to 1 up here, which one of these is bigger?
X minus 2.
No.
Or plus 2.
Yeah,
No.
the remainder.
Yes, the remainder. If X is 1.1, this is 10, and this is 3.1. If X is 1.01, this is 100, and this is 3.01. I mean, so I really want this to make sense. Which piece of this controls when X is close to 1? This piece does. Which piece of this controls when X is really big? This piece does. That's why when you're close to a vertical asymptote, that part basically takes over. It's getting crazy big. So it doesn't even matter what else is in the function. It's just going to go infinity or negative infinity.
On like an exam or like a quiz for those, are you expecting to see like a parabola in both sections of the, like over the asymptotes?
So to be honest, let me come back to the calculator. The one thing I left off here, because we didn't do it, if I long divided that, are you going to try to do it in your head right now, Jeff? Shit. Let's see. X squared, X cubed. What is X squared? X squared minus X. Shit. I don't know what the hell that is. I have to do it. Let me see. I gotta do synthetic. 1, 1, 0, 1, negative 1. Okay, right? 1, 0, 1, negative 1. Okay. 1, 1, 1, 1, 2,
2, 1, who cares? So x squared plus x plus 2. So if I do this, x squared, so what I just did was I basically long divided, right? I did synthetic because that's x minus 1, so I can't. X squared plus x plus 2. Let's see if I did that right. What I should see is that. Let me kind of go back to normal zoom. There. So there's in blue is the actual function, in red is the slant asymptote, right? In this case, it would be parabolic asymptote. But the function does weird shit when x is small, but the bigger x gets, the closer the function gets. Let me go up a lot. Oops, shit, I went the wrong way. No, Jeff, you still did the same thing. No, I didn't. Oh, I see what I did. There we go. All right. So the bigger x gets, the closer the blue line has to get to the red line. But when x is small, it can do whatever it wants to. So when you graph the one on the quiz, if you're going to make corrections, you need to be able to, first thing is I ask you to graph the function and the asymptote, just like it did right now. And you have to zoom out enough so you can see both sides of the function following both sides of the parabola, like this. So some of you guys are going to have to zoom out quite a bit. And you can either use zoom out, there's an actual zoom out function, or you can use window and just directly change it. Make it 100, make it 200, whatever you got to do. Are you guys understanding that? Does that make sense? No? Maybe? I got 1 thumbs up. Everybody else is like, I got 2. And everybody else is like, don't let him know anything. Okay, there we go. I got a gotcha and 2 thumbs up. I feel pretty good. For a math teacher, that's a pretty high percentage of understanding. Okay. I think the rest of you guys might get it. I don't know. You're not letting me know. Anything else from the quiz or from homework? Okay. So what we're going to focus on today, if there's nothing else from the quiz or from homework, we're going to focus on the properties of logarithms. Can somebody remind me, what's the answer to a log always? Like physically, that's not the right word, but what is the answer to a logarithm? What's it represent? Always.
A power.
A power. So the properties of logs have to be the same as the properties of powers, because logs are powers. You with me? Now that's nice to say, but then you're like, what the shit does that mean realistically, practically? What does that mean, Jeff? All right, so let's do that. Let's go there. Let's see. All right. I'm realizing that, well, we'll find out how this goes. I should have done this beforehand, but too bad for me. Let's see if the properties are pretty straightforward. It gets a little funky when you're trying to prove them. So let me do this. First off, let me do the non-technical discussion, and then I'll do the more technical proof. Okay, so when I have like bases multiplied, what do I do with the powers?
You add them.
Add them. So if I have, let's say, log base x of, how do I say this? A times b. So this is kind of like me saying, what's the power on a times b? So what is the power on x squared times x to the 7th? Isn't it 9?
Yeah,
Isn't
true.
it 2 plus 7, right? So the power on a times b is the power on A plus the power on B. You did not expect that, did you? First thing is, I really want you to realize, how do I say this? For example, how do I say this? There's nothing to do with distribution here. Does everybody understand what I'm saying? There is no distribution here, right? For one thing, this is times, but for a bigger thing, this is not log times this. This is log of this. So nobody should be asking me, how did times become add? Because I didn't say that anywhere here. So this is, do you guys kind of get what I'm trying to say?
So the log x belongs to both the A and the B.
Well, so here's the idea. All right, so I'm sort of halfway between concrete example and idea. So let's do this. All right. So let's say I want to investigate this. All right. So let's say that, let me think, how do I want to say this? Yeah. All right, let's say that A is x to the m, and let's say B is x to the n. So everybody with me so far? Nothing amazing. Stay with me, stay with me. This is going to be a little dry. I'm sorry, it's just the way it is. Okay. So what is log base x of A? Let's see if you guys can remember. What's log base x of A?
X to the m.
No.
It's just m.
M. Because this, what is this asking me? What power is on x to make A? M is. Right? Isn't that what this is asking me? What power does x take to make A? M. So what's log base x of B?
N.
N. 11. All right. Now, let's see. So what is, how am I going to put this together? This is the part that I haven't done in a while. So that's what I was worried about. How would I do, let me see, how do I want to do this? Oh, okay. What would this here be? This would be log base x of x to the m times x to the n, right? So let me give myself some more room. Let me put this up here. Okay, I am going in the right direction. I like it. So I'm trying to investigate what this is. Stay with me. So is everybody with me so far? What does this shit mean? We just made some shit up. This is the most general shit, right? So it's got to be related to the actual base on the log to make sense for it to be discussing a power. So I've got this means this means this. Okay, all nice and together. And I want to know what the hell would that mean for this. So let's see, log base x. A is x to the m. B is x to the n. And then what can I do inside, of course? Same thing we did up there, right? Is everybody with me? Now, what is this? What's log base x of x to this? You can do it. What's the log?
M plus 1 or n?
M plus n. But what was m? And what was n?
Log x.
So what is this? It equals this. All right, so let's do a couple of concrete examples. So I really want you to understand this is the property of powers. What's the power when I multiply two things with the same base? It's the sum of each power. That's what that says. So For example, some kind of boring examples. What would log base 2 of 2 cubed times 2 to the 4th? That would be log base 2 of 2 cubed plus log base 2 of 2 to the 4th using the property, right? Log base 2 of something times something else is log base 2 of 1 plus log base 2 of the other. What's log base 2 of 2 cubed?
3.
3. It's log base 2 of 2 to the 4th. 4. So I get 7. Right? Now listen. I really want you to understand. This is not the most important property in one sense, but it gets everything else going. So far, this seems very anticlimactic. Ooh, I could have done that shit at the beginning, Jeff. That's 7, so log base 2 at 7. Well, I didn't need this. Okay, I understand. But we have to have this, and then we can do the other two properties. The second property should make all the sense in the world. I could do exactly what I did here. The second property says log base something of A over B. What do you think that's going to be? Again, if we're doing all the properties of powers.
Minus.
Yeah, so this is going to be log base x of A minus log base x of B. Let me give you a better concrete example for this, a little more interesting example. Does anyone know what log base, you could do it, Jeff. Sure, yes. Log base 5 of 50. Does anyone know what that is without using a calculator? Does anyone know exactly what that is?
No.
If you do, I'll give you an A right now.
Is it
You
10?
don't, huh? It cannot be 10 because 5 to the 10th power is not 50. So log does not mean divide, right? So you're not going to do 50 divided by 5. What is this asking for? What is it asking for? What's a log always asking for?
Power.
A power. The power that does what?
Makes
Okay.
5 50.
Makes 5 become 50. So what power do you put on 5 to make it become 50 is the question. None of you know that, and neither do I. Don't get me wrong. I don't know what the shit is. I could estimate it. I don't know what it is. Okay, now Kate, stay with me. Everybody with me? You're all like, great, thanks, Jeff. You showed us a problem I can't do. I feel so good now. Yeah, all right. I can't do it either. What about log base 5 of 2? Does anyone know what log base 5 of 2 is? Of course not. You're like, I already know the answer is no, Jeff. But what can I do? I can do this backwards. This is an equal sign. It goes either way. So how can I rewrite this? Log base 5 of 50 minus log base 5 of 2 is log base 5 of, how do I rewrite this?
50 over 2.
50 over 2. And what's 50 divided by 2?
25.
And what's log base 5 of 25? The
Two.
power that 5 needs, sorry?
2.
2. So something none of us could do, including me, something else none of us could do, but the property allowed us to rewrite it. Got it.
I find that cool.
Thank you. I appreciate that. I mean, go ahead, sorry.
I have a question. Like, can you graph it? Log base 5, 50.
Well, that would just be a that would just be a constant. I'm not sure what you mean. It's not a function up there, right? You mean graph log base 5 of x and then find where 50 is?
Never mind.
That's all right. No, I appreciate it. You're trying to figure out, are you trying to figure out how to get that by hand, like an approximation?
No, I wasn't sure like exactly what's going on the equation. Like, so what's the log base 525 equal to 2? Like, is it just
But But I mean, this step here should be easy, right? Because 5 squared is 25. Right? It's the steps that lead up to it that are new. And this is really possibly, now this is understandably confusing because your brain sees subtraction and it thinks it becomes division, but we know better. So be careful. Now watch. The biggest mistake I see is somebody would do this problem, but they would do this. Log base 5 of 50 minus log base 5 of 2 equals log base 5 of 50 divided by log base 5 of 2. God, if I could just write, we would all be so much happier. What did I do wrong?
That's a power over power.
Yeah, power over power. Now subtraction became division, and that's bullshit. That is utter bullshit. That doesn't mean a damn thing. This does not say subtraction becomes division. This says the difference of 2 logs is the log of the quotient of the stuff, right? That is not the same thing as subtraction becoming division. That could basically never happen generally. Subtraction just becoming division. Okay, maybe. So what do we got so far? We got this. So far we got this. And here comes the most important property is the third one. But the first two properties, we got log base something, base b of something times something equals log base b of 1 plus log base b of the other. And that is, again, just the property of powers. What do I do when I multiply things with the same base? I add each guy's power. Easy. The second one was the same idea, dividing. So, of course, it's going to be subtraction, just like laws of powers. The third one is really kind of cool. Here's the idea. What would this be? Log base b of m to the p. Ooh, I love it. What the shit? All right. Isn't this log base b of m times m times m? How many times? How many m's?
P.
Pms. Isn't this equal to log? Now, can't I use the first property over and over and over and over and over again? Do you guys see that? It kind of stacks, which is really, really cool. So this would be log base b of m plus log base b of m plus log base b of m, log base b of m. How many times?
To the p powers.
No, careful. P times. So if I had 5 plus 5 plus 5 plus 5 4 times, what is that number? Isn't it 5 times 4? 5 plus 5 plus 5 plus 5 is 5
Yes.
times 4 is 20. Okay, amazing stuff, right? So what is log base b of m plus log base b of m? P times, it would be p times log base b of m. Now watch this shit. What do you do with the powers when you're raising something to another power? Don't you multiply the powers? When I'm raising something to a power, what do I do with the powers? I multiply the powers. Isn't p the other power? It isn't log base b of m the first power? So I'm going to multiply the powers. Another way to look at this, what does a log do to a power that's on the what's inside? Brings it out front. It just comes down.
I'm a little confused by what you drew on the bottom.
Shit. Where?
With the p times log, it just, is that like a whole division sign or is that like a line?
You gotta watch what I'm writing first, and then I start marking it with shit that I'm saying. So is everybody cool with the fact that this is this is this? And then how do I write log base b of m plus itself p times? Well, that's p times log base b of m. Let me stop right there. Is that cool? That equals that. So what's the shortcut? That power just comes down. That's the shortcut. And how does that relate to properties of powers? When I raise something with a power to a power, I multiply the powers, correct? What would this be? X squared to the fifth. What's that? What's x squared to the fifth power?
X to the 10th.
X to the 10th. Thank God. So I multiply powers when I raise one to another power, don't I? Just like it did there. So that's all that says. But a better way to look at it really is that just comes down. Bam. Or you can do it the other way. I can go up, back up. So for example, let's see. All right, why is this the most important property? All right, let me show you. Is everybody cool with that? So the other stuff I had written up there was just something I was talking about. So I'm sorry about that. So let me make sure we all are cool with this last property. I'm going to erase all this. Here we go. So how do I rewrite this? Log base b of 10 to the a. What's one way I can rewrite that?
A times log b to the 10th.
Yeah, a times log b to the 10th. Not do them carefully.
Yeah, I get it.
Log base b 10. Yeah, I like it. So if the argument is itself being raised to a power in a log, that power can come down. When would I use it? Whenever it's useful, right? So let me ask you this. How would it, let me see. All right. We're not going to have to do this at first. How would you solve this? I'm pretty sure I've talked about this before. How would you solve this equation? 9 to the x equals 27. Does anyone remember how to solve this by hand, completely by hand? What are these both based on?
You factor.
Factor of 3.
3. So this is 3 squared. So this would be 3 to the 2x. And 27, of course, is 3 cubed. And remember what we talked about? What must be true about the powers here, since the bases are the same?
2x equals 3.
Yeah, does that make sense? 3 to something equals 3 to something else. No, these have to be the same for the equality to be true, correct? So 2x must equal 3, so then x is 3/2. And why does that make sense? Because half of 9, so 9 to the 3/2, half of 9 is 3, and 3 of them is 27. Okay, maybe. Now, can you do the same thing here?
Not off the top of my head.
Oh, hell no. Not off the top of anybody's freaking head, right? Are there any common bases for 5 and 111? No, nothing nice, right? You with me? They're both based on 2.7 with some funky ass power. So I'm not going to use 2.7, of course, right? I want some nice whole numbers. So we currently have no way to solve this by hand. Well, until we talked about this. What function? What's the only function that can save my variable? Where's my variable stuck in this equation? It's stuck where? Up in the power. What's the only function we know of that can take something in the power and bring it back down?
A log.
Log, holy shit. So what we normally use, what math people normally use the most is natural log. You want to know why? Because I only have to write 2 letters instead of 3. So ln instead of log, right? So if I take the ln of both sides, let me write this on the next line just so you guys really know. I'm going to take the ln of both sides. All right, this looks so freaky, but can somebody remind me? Side note, I have no idea what your notes look like. I don't care. Side note, how would you officially solve this? How would you show me your work? What would you do to both sides? What would you do to both sides?
Square root.
Cube root. Right? Cube root both sides. And then you could do shit. These kind of cancel, and this, you could figure that out. Okay, whoop-de-doo. So here, that's all I'm doing. I am taking the natural log of both sides, the same way I took the cube root of both sides. They're just functions. We're still not used to a function that looks like this, though, right? But still, it's just a function I'm taking to both sides. Why did I take that function? Why did it take the cube root? Because that's the one that's going to kill a cube. Why did I take the freaking natural log? Because a log is going to bring that x down. So how do I get x by itself?
Divide.
So, yeah, divide by.
Natural log 5.
Holy shit. Yeah. So there it is. Now this is not satisfying. Are you with me? Is that satisfying? But that is the answer. This is the only way to write the answer exactly correct. Now, do you guys see your natural log on your calculators? Can somebody try to do this in their calculator? By the way, what's 5 to the third power?
75.
125. 125. So shouldn't the answer here be just a little bit less than 3 to make it become 111? So you know your answer should be 2.8.
I got 2.926.
I like it. So let me show everybody in case anyone's having trouble with your calculator. Shit. Jeff, what are you doing? All right. Pushing all kinds of buttons. Here we go. Clear all this away. So I would do ln is going to be right there. That's nice. ln. Oh, it opens a dumb parenthesis. I wish it didn't. I should put them there if I want them. It's not Microsoft Word. Looks like you need some help, Shep. ln of 111 divided by ln, what was it, 5. Bam. So there's your 2.926. How do I check that? Watch. I'm going to do 5 to the answer. Do you see that? Because remember, ANS holds the last number. And what is that number supposed to do? It's supposed to be the power 5 needs to become 111. And there you go. 5 becomes 111 if I use it. It's a beautiful way to check. Sorry?
I said cool.
Oh, okay. I agree.
Yeah, I did it just a second ago.
All right, let's see. Okay. So that's pretty flippin' powerful. Before today, you had no way to solve this equation, by hand. And we get the answer, but this is still not very useful. But it is a form that I can throw in the calculator. I couldn't do shit with this. Nothing. All right, maybe. So here, you guys try to solve this. Let me see. Of course, I'm going to up the ante now when it's going to be you by yourself. So let me up the ante. So what about, what do you got, Jeff? 7 to the x minus 1 equals 5. I like it. Oh, I'm so evil. Let's try that problem. Oh, yeah, that's true. By the way, we're sort of, all right, let me make sure you guys understand. Section 6.5 is log properties. And we're sort of right now sneaking into section 6.6 a little bit, believe it or not. But this one, hopefully you guys realize, I mean, you got to be a little more careful because it's not just X. I'm going to start to catch up to you guys. Let me see. So ln. You guys with me? So on a test or a quiz, assuming I remember to do this, I will ask for an exact answer. That's the exact answer. And I'll ask for an approximate answer. And that's what you get when you throw it in the calculator. People think that just because there's a lot of decimals on an answer, it's the exact answer. No, because when will those decimals end? Never. So you can never get the exact answer when you start writing decimals. That's the exact answer. Now, what do you guys get as an approximation? Has anyone done that yet?
1.83.
1.83? Let's see. I haven't even done it yet. Let's see if I can get that. Whoa. Okay. Jeff. That's funny. All right. Yeah, 1.83. I like it. 827, blah, 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 blah. Okay. I like it. And how do you check that? You would do 7 to the 0.83. Now, if you round a little bit, it's not going to be perfect. But if you do 7 to the 0.83, you get 5.02, blah, blah, blah. Does that make sense, everybody? So you can always check your work. How do you check your work? Same way you always have. You throw the number back in. Right? The more you round, the more off it's going to be from what it's supposed to be, but it should be pretty close. Okay. Love it. All right. I think that's pretty good. I mean, I got further than I... Oh, yeah. I know why I got further, because let me show you this. I completely forgot. We're not going to do this right now. I'm going to let you guys go, but let me show you this. Maybe we'll do this first thing next time. I do have a worksheet up that we're not going to do right now because I meant to do it earlier and I totally forgot it was up here. So if you go to modules and go to unit 6, you can only see the ones that are marked in green there. So you'll see properties of logs. And what it is it just has the log properties with examples to try. And then it's got kind of a overall review of what we've done with logs so far. So I think we'll do that. Let's do that first thing tomorrow. I desperately want to give us all an early night, a little bit early, unless anybody has a major opposition to that. Nothing. Okay, good. Thank God. So this is it. That's good. That's good for tonight. Let me know if you need to hang out, if you have any questions. Otherwise, I will see y'all tomorrow.
I have a question for
Yes.
what's the difference between natural log and the logarithm?
They're both logs. So next time what we'll do is we'll actually do another one of these problems, and I'll show you that no matter what log you use, you get the same answer for these problems. All a natural log is log base e. That's it. So you could have log base pi. You could have log base square root of 7, right? So
Yeah.
all natural log is we decided to give it its own little symbol because e is special. So we don't have log base e. We just write that as ln.
So if you write natural log 5x, is it the base or
How do you wait?
like for example, if you say natural log 5, the 5 represents a base.
No. This means, and again, I don't believe you're making me do this. I said I would never write this again. This means this. The base is e.
Okay. So 5 is the
Argument. 5 is the inside.
some something to
Yeah.
Keep-
E to what power equals 5? That's
okay, cool. Yeah.
And I would estimate about 2 because E is just under 3 and just over 2, right? Yeah, it's a little less than 2. But anyway, does that make
Yeah.
sense? So it's a special base. So we gave it its own little symbol. So like log base 10, we don't even write the 10 because it's the most used one.
Yeah. So natural log 5 is basically the power.
Yes, the power that E needs to become 5.
Oh yeah.
Yeah.
Thank you.
You're welcome.
Have a good one.
You too.
I have
How's everybody else?
something
Oh,
funny that's not totally related.
I could use that.
Can I share my screen for a sec to show you the funny thing?
Oh, I don't know.
I don't know. I think it works.
What is it?
It's a video of my cat because he jumped up on this table to watch class and he started fighting you. And I thought you guys would want to see it.
Oh, that's funny. All right, let's see it. You should be able to share now.
Okay, share. He just
Oh,
he
yeah,
really
yeah,
he really wanted out and
the
he was
laser.
annoyed and then he got distracted. He sat there for a while. And when you dropped this, he started fighting like your arms. It was good.
Pretty funny. I like it. Well, all right. At least
Anyway.
that was paying full attention. I like that.
I thought it was important. I don't know.
No, you're fine. That is pretty funny. I like that.
Have a good night though.
You too. Take care.
Yeah, good night.
See you. How's everybody else? You all good?
Yeah, I have a quick question just about what we talked about earlier for my quiz / midterm.
Yes.
Yeah, you can just do the thing where you said you just throw it on the midterm, but does that mean you're going to give me like a small extra bit of time for like the additions of the 5.5 and 5.7 on the midterm?
So here's what's going to happen. You're going to take the exact same midterm. It's just going to count for a little tiny bit more to cover the missing quiz. So I'm not going to throw extra questions at you. It's just the quiz is going to cover that same material. I mean, the midterm is going to have that same material on it. So one option, if you miss a quiz, is I can just count the midterm or the final for a little bit more to cover for that missing. Yeah.
And then I know you said that you didn't put any 5.7 problems on the quiz. Are there going to be 5.7 problems on the midterm?
Oh, hell yeah.
Okay. And then one last question on kind of some old homework that I've been getting ready to turn in. On 5.6, number 45, it's just asking about the asymptotes, and the denominator is x squared minus 1, but the answer key says that the vertical asymptote is only +1 and not -1.
Which number again?
5.6,
45.
Oh yeah. So all right. So this is that part about. So how do you? So factor the top and the bottom.
Yeah, I got all that.
All right. So what do you get on the top when you factor it?
It's x plus 3, x minus 1, and x plus 1, x minus 1 on the bottom. Oh, is it because they cancel out?
Yes.
Okay.
So see, this is not so normal. If that wasn't there, so if it was actually this, then when I get close to 1, this piece was going to grow like crazy. So no matter what these do, the answer is going to be huge. But since it actually has an x minus 1 on the top also, it kind of is kept in check. So as small as this gets, this obviously gets equally small.
Okay. I guess I just
So
overlooked. Yeah, I just overlooked that part.
What it's going to do then is at x equals 1, there's going to be an open circle. It's what they call a removable discontinuity. Meaning, I always think of it as like a pothole I can fill in, right? It's just going to be an open circle.
Thank you.
You're welcome. Okay. Everybody else okay?
I had a couple of math questions for 6.1.
6.1.
Yeah. I was still confused on 57 when you explained it earlier. Because I was looking also at the answer key and it shows like APY equals A like parentheses T minus A over A, and I don't understand.
No,
Also, like,
that's not.
yeah.
Wait a minute. Let me double check the answer key. What is this? 6.1.
Yes. Number 57.
6.1. 57. Oh, you're just looking at the beginning of the problem.
Mm-hmm.
Yeah, no. Yeah, no. So they have, okay. I don't know why they have, all right. So they're using different letters than what we use. For some reason, they use a little a instead of a P.
Okay.
That's dumb. They use A of T, which is officially what the formula is, but we just normally just put an A there for amount. So if we replace A of T with A and lowercase a with P, it's exactly what we did.
Oh, okay. Because I was so confused. I was like, where did those A's come from?
They just randomly decided to not use P. I have no idea why. That's dumb. So,
Okay. But it's basically like the same gist of like what you showed earlier. Okay.
exactly the same. They just chose to use different symbols for I don't know what reason. Yeah.
And then my other question was number 60.
So 60 is exactly the same thing. It's so let me see here. They're actually giving us, there should be a P there instead of a little a, but who cares? It's the same thing. You take this minus, little a if they want to use little a, divided by little a. And then of course you're going to end up here. Right?
Are you sharing something?
Oh, I'm sorry. Sorry.
Okay.
All right. I thought I still had it, but I guess I turned it off. For some reason, they're using a little a again instead of a big old P. But what did we do? We took the amount at the end minus the amount at the beginning divided by the amount at the beginning. So all the A's would cancel out and you would end up with this. Bam, done.
So that's what all the A's are standing for. Like
big P.
it's just P. Okay.
Yeah. So I don't know why they decided
yeah.
the A. I have no idea.
So you're just doing big like the A minus the other A divided by A.
And I really want it to make sense because to figure out the interest, you take the amount at the end minus the amount at the beginning. That makes sense. That's the interest. And if I divide that by where I started, that's the actual percentage change from where I started.
Okay.
And that's when all the A's cancel and you end up with a beautiful little equation.
Okay.
Yeah.
I think I got it. All right. Sounds good. Thank you.
Let's see. Everybody else, you guys good? Charles?
Yeah, I had a quick question. Your worksheet and video you did for 5.4, 5.6, super helpful for the quiz. I was wondering, are you going to do one of those for chapter 6 for the midterm? Just kind of like.
Oh, I'm going to do one for the midterm. So I'm going to put a practice midterm up sometime this week. And then over the weekend, probably over the weekend, I'll make a solutions video for that.
Oh, okay. Awesome.
Yeah. So that's
all right. Well, thank you.
Sure. Cool. All right. Anything else? Everybody good? Okay.